All right, geometry 8-2, the Pythagorean theorem and its converse. So we're going to get right to it here. The Pythagorean theorem, some of you might remember from algebra, hopefully. If not, we're going to look at it right now. We have a right triangle. It's got this right angle here. This is side A, this is side C, and this is side B. This side here is called the hypotenuse. This is the side that's across from the right angle. The hypotenuse is the longest side of a right triangle. It is across from the right angle. This side here and this side here, these are called the legs. Now, the Pythagorean theorem says if I take this, if I square one leg and I add it to the square of another leg, then I get the hypotenuse squared. So this is the Pythagorean theorem. These are the legs that I square and then add to one another, and then the hypotenuse is hypotenuse is equal to those. All right. Anyway, I didn't say that awesome, but you can see what I mean. So we're going to get right into some examples here. Find the missing measures. Okay, so I have a right triangle, and this leg is 6 and this leg is 15. And so I need to find out what x is. X is the missing measure. And so all I do is I take the leg, I square it, add it to the square of the other leg, set it equal to the hypotenuse squared, and go from there. So let's see what that looks like. X squared plus 15 squared, so those are my legs, equal the hypotenuse squared. All right, 6 squared is 36, 15 squared is 225. You might want a calculator ready for this rest of this lesson here. And then equals x squared. 36 plus 225 is 261. Equals x squared. Now I take the square root of both sides. And so this is going to be a little bit of a mess here, but that's all right. I know that 3 goes into 261 87 times. And then 3 goes into 87 29 times. 29 is a prime number. So x equals 3 times the square root of 29. Or you can put it in your calculator, and it's about 16.2. Generally on a test, I'm looking for more of these kinds of answers. If it says exact answer, that's what I want. It needs to be in a radical sign. If it says round it, then you can just plug it into your calculator and round it to whatever it says to round to. All right, let's do another example. I have a right triangle. There's my right angle. Here's x, here's 9, here's 11. Okay. Now, for this example, I need to well, for all of these Pythagorean theorem deals, I need to figure out which are the legs and which is the hypotenuse. So I'm going to find the hypotenuse by finding my right angle, and I look across from the right angle. There is my longest side. That is my hypotenuse. So I'm going to say my hypotenuse squared equals my legs squared. X squared plus 9 squared. My legs and my hypotenuse. 11 squared is 121, x squared plus equals x squared plus 9 squared, which is 81. I'm going to subtract 81 from both sides. I'm going to get x squared all by itself before I take the square root of both sides. It's way, way easier that way. And so now I get, what is that, 40 equals x squared. Take the square root of both sides. The square root of 40 is not 20. The square root of 40 is 2 times 20, and 2 times 10, and 10 is 2 times 5. So I've got these two 2's here, and this 2 and this 5 are stuck. And so x equals 2 times the square root of 10. Or if you plug it into your calculator, x is about 18.4. Oh no, sorry, not 18.4, that's a different answer. 6.3. That makes weight. I'm like, how did I get 18.4 from there? Okay, 6.3. That makes much more sense. All right. Now let's have you do 2. You try. Here is a right triangle. Here's my right angle over here. 17 and 7 and x are your measures here. I want you to find x. Here's another you try, and this one looks like this. Right triangle, 22, x, and 25. All right, I want to know what x equals for this one. I want to know what x equals for this one. Go ahead and do the you tries, pause, and get to work. All right, let's see how you did. Now this one, I'm going to identify my hypotenuse. My hypotenuse is x. And so I'm going to say x squared equals 7 squared plus 17 squared. So x squared equals 7 squared, which is 49, plus 17 squared. 17 squared, I did not write it down from last time, so I'm going to just put it in my calculator here real quick. 17 squared, or 17 times 17, is 289. And then if I add 49 to that, I get 338. So x squared equals 338. Take the square root of both sides. X equals, okay, 338 is 2 times 169. 169 is 13 times 13. So I've got the 13 I can take out, the 2 stays in here. So x, I wrote that in the wrong spot, it should be right here. X equals 13 times the square root of 2. Now, for this one, if I were to plug that in the calculator, I would get 18.4. Now let's do this other you try. Hopefully you could see that. I'm not sure if you can. There it is if you didn't. Here's the other one. So my hypotenuse is 25, so I'm going to take 25 squared equals x squared plus 22 squared. 25 squared is 225, isn't it? 25 times 25. Oh, 625, that's right. 625. Of course, it's not 225, that's 5 times 25. X squared equals 22 times 22, which is 484. Plus, not equals. Subtract 484 from both sides. And I get x squared equals 141. Take the square root of both of those. And x equals, okay, 141 is 3 times 47. 47 is prime. So x equals the square root of 141, because I can't break that one up enough to take anything out of it. So the square root of 141 is approximately 11.9. So I'm just rounding to the nearest decimal there. Okay, let's keep moving here. So we're going to write a chart real quick. Common Pythagorean triples. And what I mean by triples is these are common triangle proportions. So what I mean is 3, 4, 5. If I have a Pythagorean, if I have a right triangle Sometimes I find a right triangle where a leg is 3, another leg is 4, and the hypotenuse is 5. And you'll see that over and over again in our book. Another common one is a 5, 12, and 13, where these are 2 legs and this is the hypotenuse. Notice the biggest one is the hypotenuse. 8, 15, and 17, not quite as common. And 7, 24, this is a 7, 24, and 25. So 2 legs and a hypotenuse, 2 legs and a hypotenuse. These two you see quite a bit. These ones you don't see quite as much, but these are some fairly common ones. And so you see 3, 4, 5, but it's really can be 3x, like whatever this scale factor is, 4x and 5x. Same with this one, 5x, 12x, 13x. This x is, I'm going to multiply each of these by the same number, 8x, 15x, 17x. And it can be, it just expands the triangle. It's a scale factor. And so these common 90-degree triangles, or right triangles, might be, they would be in proportion to these here. Okay, so let's look at something here. Pythagorean inequality theorems. So I have a triangle. This is not a right triangle necessarily, but it is acute. It doesn't totally look acute, but it is. It's acute. And A, B, C. So if I take B squared, which is the longest side, then if this is an acute triangle, then A squared plus C squared needs to be bigger than this, not the hypotenuse, because this is not a 90-degree angle. This is just a triangle that's not a right triangle. So the longest side, it needs to be smaller than the 2 smaller sides, smallest sides. So in this case, triangle ABC is acute when each angle is less than 90 degrees. Remember, each angle is less than 90 degrees. Okay, let's draw another triangle. This one is going to be obtuse. So A, C, B, obtuse triangle. This time I've got C squared, which is my longest side. That's the one across from the obtuse angle. C squared is going to be bigger than A squared plus B squared. So notice when I have an obtuse angle, the longest side is going to be greater than the 2 sides squared. Remember, triangle ABC is obtuse, meaning it just has one angle that is greater than 90 degrees. The other 2 are always going to be less. All right, let's use this information to do some examples. Is it a triangle, obtuse, or acute? All right, so here are our numbers, 7, 14, and 16. Okay, so what I'm going to do here is, in order to find out if this is a triangle, this smaller side has to be less than these two sides added together. And this side has to be less than the other two sides added together. And then this side has to be less than the other two sides added together. 14. So in order to decide if it is a triangle, we need to set this up. Is each side less than the other sides added together? If this is true, yes, it's a triangle. If not, then it's not a triangle. So let's see. 14 plus 16 is definitely over 7. That's 30, right? 7 plus 16 is 23. That's greater than 14. And then 7 plus 14 is 21, which is greater than 16. So yes, this is a triangle. Yes, a triangle. Okay. Now, is it obtuse or acute? So here's the obtuse or acute section. So what we're going to do here is we're going to take the largest side, and then we're going to set it, we don't know, is it greater than or equal to, I don't know, greater than or less than the two smaller sides, 7 squared plus 14 squared. Okay, oh, it should be 16 squared, right? So 16 squared is 256. And then we've got 49 plus 196. 256 is what? Then 49 plus 196 is 245. Okay, 256 is greater than 245. So what do we have here? If this longer side is greater than the two smaller sides, then we have an obtuse triangle. Okay, here's a U-try, and then we're going to be all done for this lesson. Okay, first, is it a triangle? Triangle? Yes. Acute or obtuse? Here are our numbers, 11, 60, and 61. Okay, first set up each one, each side less than the numbers, see if that's true, and if that's true, then find out if it's acute or obtuse. Okay, go. All right, let's see how you did. All right, here we go. 11 is less than 60 plus 61. That's true. Okay, 60 is less than 61 plus 11. Yep, that's 72. Okay, so that's good. Now, the last one here, we're going to do 61 is less than 11 plus 60. That's 71. So that's good. That one was 72, right? Yep. So anyway, all right, that's good. Yes, it's a triangle. Now, is it acute or obtuse? Okay, so now what I'm going to do, I'm going to find the longest side, which is 61. Squared is something to 60 plus 11. 60 squared plus 11 squared. Okay, so let's get out the calculator real quick. And I've got 61 times 61 is 3,721 is something to 60 times 60, which is 3,600, plus 11 times 11, which is 121. I add those together, I get 3,721 is something to 3,721. Oh, wait a second, they're the same number. What happens if they're equal? Well, remember, the Pythagorean theorem is c squared equals, or well, let's write it the way that we know it, a squared plus b squared equals c squared. So this is a right triangle, right? So this is for a right triangle. If it's equals, it's a right triangle. It's right. It's not obtuse or acute. It's right. This one is a little bit of a trick question there. But there it is. All right, good luck on the homework, 8-2.